This lesson is called Silos, Frozen Yogurt, and Popcorn, and we're going to be calculating the volume of lots of different problems that involve cylinders, cones, and spheres. And some of these types of figures are going to be called composite figures, and those are just combinations of those three types of figures put together. So let's get started. Now, in order to solve some of these problems, we're going to have to remember some of the formulas that we needed before. So first of all, the volume of a cylinder is pi r squared times the height. It's just the area of the base times that height. The volume of a cone is very similar to that of a cylinder, and the volume of a cone is 1/3 pi r squared times the height. And last but not least, we have the formula for the volume of a sphere, which is 4/3 pi r cubed. And in that one, all you need is just the radius in order to calculate the three-dimensional volume of the sphere. So now that we remember our formulas, let's look at this example problem. So in this problem, we're being asked to compare the volume for the cylinder, sphere, and the cone. We're probably going to list these from what's the biggest to what's the smallest. And if you're just looking, it's hard to know which one's going to have the largest volume. So let's do some calculations. So in this situation, I already have my formulas for each underneath the appropriate figure. So when I look at this one, I know that I'm going to substitute in my values, and I'm going to substitute in V equals pi times the radius, which is 2 squared, times the height. Those are given to me. And in that calculation, that ends up being right around 62 83/100. And I'm going to make sure I include my units, which is inches cubed. In my next one, I want to substitute in, I know that the radius is 3, so volume equals 4/3 pi times 3 cubed. And using my calculator, not the top of your head, you should punch that in for sure, is 113 1/10 inches cubed, approximately. And in that last one, I'm looking at those, like that's almost double. That sphere is almost double that of that cylinder. So there's a lot of volume within that sphere. And then last but not least, volume equals 1/3 pi times 3 squared times the height, which is 4. And in this situation, that gives me approximately 37 7/10 inches cubed. So if I'm looking at this and I want to list them from greatest to least, so the sphere has the greatest volume, and the cone has the least. And that cylinder falls right in between the two. So that's one type of problem that you may encounter where you're comparing 3 different dimensions, and you'll need your 3 different formulas to figure that out. But I also want to make sure that you understand you might see some real-world application problems. So in this situation, I'm given a silo, and this is an example of what a silo looks like in case you're not familiar with that. It holds grain and stores food for animals over the winter. So at the top of that silo is a hemisphere. And a hema, like that prefix there, just means it's half of a sphere. That's going to be really important for us to remember later. So here's that hemisphere. And then I'll also know that this silo has a cylindrical body, that one's hard to say, body. And I'm going to highlight that in pink, and that is shared. So in order to calculate the total amount of volume that that silo has, I'm going to need to add these two together. So I'm going to add half of the volume of a sphere plus that of the whole cylinder. I have the whole cylinder, not half of it. So now let's take a look at that problem again. So I'm going to substitute in my values, and in this situation it tells me that it's a radius of 8 feet, and that radius of 8 feet is the same for the cylinder as well as that sphere. So this is 8 feet, and I also know that the height of this figure is 40 feet. Get that closer together, sorry about that. So this is 40 feet. So now I'm going to substitute in my values in my formula. So V equals, I have to remember, it's just half of that volume of a sphere. So I'm going to make sure that I do 1/2 times the 4/3 pi r cubed. Make sure I get that calculation. And then in my volume of the cylinder, that's pi 8 squared times the 40. So in this situation, I can go ahead and do those calculations. I want to make sure that I do the 8 cubed first. This ends up giving me somewhere around 1,071 79 feet cubed. And in this situation, the volume is approximately, once I substitute in all those values, 8,038 4/10 feet cubed. And now in order to figure out the total volume of that silo, I want to add those two numbers together. And my total for that composite figure volume of the silo is 9,110 19 feet cubed. So that's how you're going to figure out when you see composite figures together, think about what three-dimensional figures make up that composite figure and use your formulas appropriately. Good luck. It's a lot of fun. You're going to need to remember those 3 formulas and maybe some from previous topics, but you should have no problem finding out the volume for these figures.